So without further ado, I do want to invite Alex, who is from Pantera. He's the head of research with a lot of research background. I assume he will dive into the automation of web application testing and will tell you more about this specific topic. So Spivy, the stage is all yours.
Thanks, Leo. Hello, hello everybody. So my name is Alex. I'm the head of research at Pantera. And what we do at Pantera is in the research team, we build on top of automation platforms, we build various attack vectors and attack infrastructures that interchange data in order to create automated penetration testing experience. One of the platforms that we've added in the past year is the web app attack platform, and I want to share our perspective on this platform and to show that maybe web application is, it's a huge domain in the world of hacking, but using automation, even the most experienced pen tester can benefit from automation, because the automation will help finding the low-hanging fruits. It will help to find, to do very tedious tasks, but give a lot of value in the penetration testing process. And I think that automation will never be able to replace, an experienced pen tester, but automation can assist in making the time of the pen tester to be used to a good value. So the proposed approach in the domain of web applications is, first, once I have a web server and I have the application, I will describe the main phases. The first phase, create a crawler. You need to, and I will elaborate, but crawling basically means learning from links and smart guessing the various routes of the web application. Then the next phase is to derive attackable assets. And when I talk about attackable assets, it means that when you get the web page and you get all the parameters and get the responses and get all the metadata and the headers from the server, etc., you want to extract the bits and the pieces and to put focus on specific pieces of information that can help propagate the attack. And this is basically phase 3. What are the ingredients in order to establish this type of automation and to achieve those 3 phases? Have the Firefox or Chrome installed on the pen testing environment. Have the web driver for the corresponding web browser, and basically the web driver it's a local server where you can control it, and the web driver interacts with the browser. And I will explain why using a real browser and a web driver is better than using some sort of HTTP library-like requests. We are also using Selenium client. Selenium is basically used for QA automation of web apps. We are using it to automate the penetration testing scenario. And of course, Selenium, you have support in your favorite programming language or scripting language. And because we're using Python, we're using Selenium Wire, which is an extension to Selenium, and it gives us the ability to inspect the requests that are made and also to investigate the response in terms of parameters, headers, etc. So phase 1 is the web crawler. So the goal in this phase is to discover web routes. Okay, and how do we discover different types of web routes? You can start with the main landing page and start clicking, and because you're using Selenium, you're basically clicking on links. Start clicking on links, and you click a link, a request is sent, you get the parameters, you get all the headers of the response, you have the body of the response as well. Keep track of those, okay? And of course, my recommendation to you, limit yourself to the scope of the tested domain if you're using it externally, because in each web page, you have references to other to links, for example, images that leave the domain of the tested application or the IP address of the web server itself. And make dictionary-based access, because not every route that exists on the web app is accessible through links, like, for example, administration pages, etc. So once you've mapped the existing paths, you can append, do a guessing and add, create a whitelist of possibilities like PHPMyAdmin or the WordPress admin webpage, etc., and paste it to existing route and test those as well. If the hit is successful, great. Now you have another route. If not, it's automation, so it didn't cost you anything. Track records of every type of information, which method you used, get, post, the URLs, the parameters, the headers, the body, and of course, keep track of the response. Now that I've mapped, maybe I haven't mapped all the possible routes, but we did a pretty good job. Now it's time to derive attackable assets. And what does it mean, deriving attackable assets? A few examples. So in our asset analyzer, for example, one of the first things that I want to extract, I don't want the whole page. I don't want all this messy HTML. I want forms. Okay, I want to extract forms because there are many types of forms, and forms, from a pen testing perspective, it's a way to interact with the server. To attack something, you need to interact with it. So the most important thing, forms. You will have login form. We will talk about this use case in a few slides. You have file upload forms. Once you extract the forms, and extracting forms is very easy, especially with Selenium, when you're scripting it out. Once you have all the forms mapped, you can later say, please give me all the forms. I want to try to interact with the server, and forms is one of those ways. Supporting technologies. Once you have the requests, for example, you can use Webalizer, the dictionary Webalizer, and maybe you have this extension in your web browser that gives an icon of all the existing technologies like React or WordPress or something like that. This can help you with understanding if there are common vulnerabilities in the supporting technologies of the website in question. And during my talk, I see a question about CSRF. I will talk about CSRF in the form in a few slides. Error pages. Error pages are great because error pages is when you send a request. It said, hey, the database didn't react so good with the request. Here's the error, some SQL error, etc. Those types of error pages, which are indicated by a response code of 500, between 500 and 600, it's a great mean of creating cross-site scripting, reflected cross-site scripting attacks. And of course, you can map non-JavaScript HTML, CSS, PHP files. I mean, not web-related files, because hey, if for some reason I find non-HTML, not web page related file type, maybe it's an Excel file, maybe it's a Word file, it's worth looking at it, because maybe it's not an anomaly, but it's something weird and something that not usually exists on the web server, and it's worth looking at it. And sometimes you may encounter Microsoft Access database file and so on, administration pages. And now let's talk about attack propagation. And attack propagation, there are many attack propagations. What does it mean, attack propagation? It means, hey, I found some interesting asset. Now I want to take this asset and I want to create an attack because we're using automation. Okay, so there are many types of attack propagation. Let's talk about, hey, now that I have the forms, I extracted all the forms, I want to create a scenario of brute forcing the login page. It's one of the OWASP categories for web attacks, brute forcing. If you have some default accounts of the login page, and you have a dictionary of usernames and password, and you want to check that, hey, my website is not prone to common username, password, and so on. Let's call default creds assessment. So first thing, I have the forms. How do I find the login form? Okay, so once you have a form, first of all, you can look at various types of the input, and because maybe this can be like a talkback, a comment in to an article form. But how do you know that the form is a login form? One of the best ways to understand it in a quick win is if you see a field which indicates the username, great, but this can be a username, username in uppercase, or maybe even not a word in English. But if you look at an input type of password, where the password is black dots hidden, it can give you a good lead and good assumption algorithm, a good heuristic to say, okay, in a form where you have an input type password, chances are that this will be a login form. Okay, so and now let's talk about, okay, but if you will look at the form and you inspect the form, for example, with you will look at the raw HTML. Sometimes in form you have hidden fields. You have many hidden fields, even CSRF. And CSRF, if you're trying to create automation with a library like requests from Python, you need to take into consideration all the hidden fields as well, okay? Because you are in charge of filling those fields. But because we are using Selenium with the WebDriver, basically it's like interacting as if the user is interacting with the login page. Me as a user, when I look at the login page, I don't see the CSRF field because it's there. And when I'm working with Selenium, I need to fill only what is visible for example, what will be visible to a real human, okay? The Selenium library allows me to iterate on fields of a form and ignore hidden fields, which of course, a normal human being won't have to interact with those. And this is why the CSRF field is preserved with the value that the server gave you, but it also will be sent as if you are filling the form in a human manner. Okay, so let's talk about other fields. So maybe there will be fields which are not hidden, okay? But you need to fill those as well. I don't know, maybe you will have a field of email. Maybe you will have a field of date. And for some reason, it's a login form, but for some reason you have a radio button that you need to choose, okay? So I'm not talking about creating an artificial intelligence mechanism to understand what is the semantic there, but you need to fill something, okay? So in this case, if you have non-hidden input types, basically just, for example, in our automation, and this proves itself very well, we created callbacks, and these callbacks iterate on a login form on every field which is not hidden and give some, for example, if it's a date, we'll give a random date. If it's a checkbox, we will, because checkbox you don't need to fill it, we will leave it blank. Radio button, we'll select one of those. And now the problem is to find the submit button. Again, it's a challenge because sometimes you may have multiple buttons, and sometimes you have code obfuscation for the client-side code. So how do we find it using an automation? Again, it's not a bulletproof solution, but when you're creating an automated platform or automated tool, even if it helps you 90% of the time, it's great. Even if it helps you 70% of the time, it is great. And most of the login forms in this exam are basically the same. And how do we still handle the case of the submit button? So if the type is submit and it's not obfuscated, then great, it's easy. And most of the time in a form, you will only have one button, okay? So you can log in by clicking this button. Okay, even if the type is not submit, but most of the time it will be of type submit. So this is the proposed heuristics. If the type submit, click it. If not, and it only one button, great. If you have several, then we choose it randomly. So, and now the tricky part. I'm doing a brute force. I have my dictionary. How do I know if the response, if the credentials that I've sent, how do I know if they are valid or invalid? This is the most important thing. So, you know, in the most early heuristics, well, okay, let's check the return code that comes from the web server. But today, every web server for every login, even if the login is invalid, gives you a return code of 200 or some redirect. If it, then you cannot base your model on top based on the HTTP return codes. So what we are doing, first thing, we establish a baseline of an incorrect login. We generate a random username, we generate a random password, then we send it, and then I get the response I get. I know for sure that this is the response for incorrect login because I generate some gibberish for the username and some gibberish for the password. Now that I have the baseline for incorrect login, I can start firing up username, password, username, password, username, password, and then I compare the results based on the baseline that I have for incorrect login. And we're doing a text-based similarity, and we know if the response is very similar to the incorrect login, and if you're doing, for example, text-based similarity, you have the Levenshtein distance. If you're rendering it an image, you have a bunch of image comparison libraries. If the result is similar to the incorrect login, you know, set a threshold, for example, 90%, you know that those credentials are incorrect. But if the similarity is very low, for example, below 30% or below 20%, then you can assume that, okay, these credentials gave me a page which is very different from the login page. And our assumption that these credentials are probably correct. So by doing this, and you can find you can find if you have a login page which is prone to default credentials of some sort. So what's next? For example, now that you have the credentials, you can start the process of the crawling, okay, this time only authenticated. Do the login, and now that you have the session cookie, you can send the session cookie. Now you can have authenticated crawling. Just a recommendation: be sure that you're not running on, I don't know, some sort of web app for managing nuclear missile launch, because when you're doing authenticated web browsing, it means that you get some sort of privilege. And our tendency is to be very, it's very risky to do authenticated crawling, and it needs to be taken with care. So only if you know that this is such, the application is not mission critical, proceed to authenticated web crawling and start collecting more routes. Okay, let's talk about another sort of attack propagation I mentioned before, reflected XSS. Reflected XSS is where you engage in a user to hit a link. The user clicks the link, and the response from the server forces the client of the user to run some code on the client side on the browser of the user. Okay, so how does it usually works? You send a request, and you fill some values into you fill some values to the parameter, to one of the parameters in the web route. The server processes the request, and based on the parameter, maybe the response, the HTML that you will get, will have some rendering of those parameters. Okay, and then you can play with the input and to make the input basically a script. Okay. How will it work? I will say, okay, to my engine, in the crawling phase, I mapped all the types of requests that I have. Okay, please give me all the GET requests and all the corresponding parameters. Okay. Okay, so now I get all the requests. I have the path. It should be a GET request, not a post. Sorry, typo. I get the path and the params. Okay, so now I'm sending to the server the path. I'm sending, and I fill some random strings in each type of the parameter. Okay, random string like some sort of UID, for example, ID, and some sort of string in the name. And then I know that if the server, if in the response I will find random string 1 or random string 2 in the response, that this server may be vulnerable to reflected XSS. And then one of my inputs, I can put in the link some JavaScript code. And then if I will send it, and if I will send this reflected XSS, this link, I will send it as a phishing campaign to in a mass phishing to a big list. And if somebody clicks on it, I will be able to run JavaScript code on the browser of the victim. Okay, so this is, for example, one thing that you can do. Okay, so but now it was very abstract. If you're using in your web penetration testing, you use some known tools for finding XSS vulnerabilities like XSSER. One of the parameters for the XSSER, okay, because it's a Python tool, so you can use it in your automation. You don't need to write this example that I mentioned before. If you're using some sort of open source tool for testing XSS vulnerabilities, the input for running the XSSER is, okay, please give me a URL with parameters. And then the XSSER will try to find all sorts of XSS vulnerabilities, not just reflected ones. So by extracting all the GET requests and the parameters and sending and pipelining those into the XSSER tool, you will be able to create an automation that integrates with the pen testing tool that you are using in your engagements. Let's talk about another type of attack. Again, it's very easy to automate the lead that will help me achieve this type of to discover this type of web vulnerability. What is basically a deserialization attack? A deserialization attack. Serialization means that, okay, I have a backend object, some sort of Java object or a .NET object. In order to save this object, I want to turn it into a stream of bytes. Okay, and then I save it in a file or a database. And when I want to load this data and to turn it to a Java or .NET object in the memory, this is called the deserialization. What is basically the insecure deserialization? Insecure deserialization means that when I'm sending the web app a very crafted request, maybe one of the fields that I'm sending will be turned to a Java object, and then the Java code will do something with this object. Maybe if I send a stream of bytes, it will eventually in the server will turn to a .NET to ASP.NET object, and the system will run it. And in some cases, turning this code turning this stream of bytes into an object, and when it starts the integration with the native code of the Java or the ASP.NET, maybe it will eventually execute as a function, will eventually execute as machine code the object that you've sent. For sure, it wasn't the intent of the writers of the application, but this is exactly the vulnerability. When you're crafting a specific field, you're sending a stream of data, and eventually, instead of turning to an object which is used for display or some sort, you're writing it in such way that it gets executed. Same example as before. please give me, you want to get the request that you've mapped, okay? And in this, at this time, the parameters doesn't matter. Why is that? Is you send the request to the server, and if the server, for example, contains in the response, contains the strings view state and value, basically it means that you can use this field, and it may be vulnerable to the ASP deserialization, because you will be able to send this data as an object, and this data as an object, if it's crafted in a specific manner, will be translated by the framework like .NET and will get executed. Okay, and how do you do it? Again, once you've mapped the request and you know that, okay, this request may be prone to the ASP deserialization, and there are all sorts of ASP deserialization, one with verification and the other without verification, with default keys or not default keys. And there are many articles on how to branch out, but they are all exploitable. You will need to add to the request a tempered view state. A tempered view state is basically the stream of bytes that will be rendered on the server and will be executed. What is this tempered view state that you will send? There's an open source project which goes by the name YStore-Serial. YStore-Serial helps you add your payloads, helps add your shellcode, for example, or your command lines that you want to execute, and wrap it in a managed code stream of bytes. So you will only give YStore-Serial this project. You will get, okay, so I want to execute PowerShell, invoke web request, download and execute, and it will wrap it as a .NET object that you can send with the injected view state. What do we do next? For example, in our platform, you are able to run code. So you want to test the impact. Okay, so you can execute code. My app is vulnerable to running code on the server. You want to investigate further. You want to say, okay, what is the potential risk? If the web server is running on a low privileged, if the web server is running in low privilege mode, then maybe that's okay, still a compromise, but maybe the risk is not high. But if the web server is running admin level or something system level, then you may run payloads like Mimikatz or some sort of more aggressive payloads that can give more value to the attacker. If it's low privileged, still some harm can be done. Traverse on the file system and look for accessible files, and maybe there will be interesting data there, or deploy some privilege escalation payloads which will help you to get from a low privilege user to a high privilege user. Questions?
Okay, so guys, if you have any questions to Spivy, please write them down in the chat. There are some questions. Let's start with the first, Spivy, regarding, there is a question, what if we have a CSRF token on all forms? Does it, I think, interfere with the test that we are doing? Might it stop the attack automation?
Because if you are using a library like requests, then yes, because you need to handle this field, and it's up to you to fill it, because it doesn't remember, it's stateless. It doesn't remember what the website gave you, and you basically ignore the return CSRF. But if you're using Selenium and the web server gave you some value for the CSRF, it's exactly like you are filling this form. You leave the CSRF token as it is, because it's a hidden field and you don't change it. You just fill the username and the password, and all the other fields that the server gave you are remain intact. So basically, if you are filling the form with Selenium, you preserve the CSRF token, and this shouldn't be a problem.
Mm-hmm. Okay, there is another questions. Let's see.
If you have Ajax calls.
Yes, yes.
Okay.
Kunal, what if form operates on Ajax calls?
Okay.
How we can automate the same?
Okay, so how do we do this? I didn't mention it here, but again, when you start building the automation, you encounter more and more scenarios, and Ajax calls is something that exists, or you have dynamic web pages that generate requests, and how do you capture those? What we are doing is we've set up, I've mentioned two methods to derive routes. One of them is traversing the links, and the other one guessing. There are more ways to collect routes. One of them is setting up a proxy server, okay, where all your requests that generated from your penetration testing browser are redirected to the proxy server, and the proxy server is your component of code. So when the proxy receives it, this is also a great way to collect routes which are transmitted from the client. For example, Ajax calls. So if an Ajax call is made, it will hit your proxy server, and your proxy server can direct this one as well.
Mm-hmm. Okay. There is another question coming from Arangel. I hope I pronounce it correctly. What do you use for trying different payloads? Nuclei templates? Like if you are trying to use different payloads.
So Nuclei is a great platform. It's written in Go. It's very fast. Okay. Specifically in our platform, we don't use it. Okay. But do the pattern matching of requests and analyzing the response. You have, for example, it does it. It generates the request and says, okay, if in the response you have this type of string of this type of pattern, you are vulnerable to. So Nuclei is a great solution, and I recommend using it. We are not using it due to some other restrictions, basically, because of the software that we are working on, the existing software and the existing automation platform that we're working on with. But Nuclei is a great solution, and the concept of doing fuzzing various types of data to given route and placing various types of fuzzing the data and different parameters, and then checking the response and saying, okay, if you have this substring, then you're vulnerable to. This is an inspiration from projects like Nuclei. And by the way, it's very fast. The implementation is very good in Nuclei. And basically, we're continuing to create something in Go because the performance of Go is better than Python.
Okay, so I think there is no further questions. Guys, if you have any questions, write them down in the meeting chat. We'll also keep time in the end of the meetup if there will be more questions. So, of course. So, Spivi, you want to summarize?
Yeah, of course. So what I've mentioned here is how we're using QA automation frameworks to derive attackable assets from web application, and I recommend using those ones because it's easier than for you using HTTP libraries and analyzing the data yourself. The QA automation of Selenium helps us a lot and helps us to retrieve data very easily. Attackable assets give you low-hanging fruits, and by the way, you can inspect not just XSS or deserialization attacks. You can check. You can investigate SSLs. Okay, if you can check your certificates. You can check for stuff like, do you have comments in your code and then extract comments and then say maybe some programmer embedded some comment which shouldn't be there, like for example username, password. There's all sorts of attackable assets, and basically they are the low-hanging windows, gateways to something more major. Then take the attackable asset and try to attack it. Maybe write your own automation or throw it into SGLMAP, XSSER, use it with Nuclei, because these tools, their input is not just, hey, give me a website and I will check for SQL injections. Give me a form, give me some sort of route and parameters which I will use to play. And this space of deriving attackable assets is a great feed for very known attack tools that serve the web application penetration testing community. And you know, it's like a cliche, but try to create automation for, if you're doing something twice, try to create automation for it, because if you did it twice, probably you will encounter it on your 4th engagement, 10th engagement, and always fine tune, because the Ajax example is a great example, is where we created something, we did this automation that I mentioned in the slides, and then we saw a request made by Ajax or some dynamic content. And then, okay, so how do we deal with it? We didn't say, oh, automation sucks, it's not good. We said, how can we upgrade the existing automation to capture more types of requests? Okay, let's set up a proxy server. Now this constellation, this setup serves us in all of the web application testing. And we keep enhancing it and add, of course, we miss stuff, but we learn what we've missed, and we don't give up on automation, because automation is the main issue. We try to improve it, and it finds a lot of stuff.
Okay, Spivi, thank you very much. It was an insightful lecture.